For today's assignment, you have to perform multiple transformations on a figure, and I'm thinking most of us will get stuck on the rotation part since we don't have patty paper, and we might have forgot how to do this without patty paper. So I'm going to do number two and number three to kind of help you out. Speaking of number two, so number two, they give us the quadrilateral DEFG, and they want us to rotate 90 degrees clockwise and then reflect across the x-axis. You need to do these in the order given. So I need to rotate before I reflect. If you reflect, then rotate, chances are your answer will be incorrect. The order of the sequence really does matter. Before I do any of the transformations, I like to pinpoint where my original points are, where my pre-image lies. So these are my ordered pairs for D, E, F, and G. The reason I'm going to do that is going to help me rotate. So now that I have my original points, I'm going to go and rotate this 90 degrees clockwise. To rotate 90 degrees clockwise, the first thing you want to do is ignore your signs. So forget about the negative signs. Let's just write them all down as positive numbers for now. And what happens when you rotate 90 degrees? Your x and y coordinates swap positions. So xy becomes yx. So instead of 4 negative, or instead of 4 1, it's now going to be 1 4. Once again, I'm ignoring the signs. I don't care about the negative signs. Instead of 1 2, e will now be 2 1. Instead of 2 6, F will be 6 2. And instead of 6 4, G will be 4 6. Now we'll worry about the signs. So the way you're going to figure out whether these will be positive or negative is by deciding what quadrant you're going to land in. So just a reminder, quadrant one is the first quadrant in the top right. The x coordinate's positive and the y coordinate's positive. Quadrant two, your x is negative while your y is positive. Quadrant three, your x and y are both negative. And then in quadrant four, your x is positive, but your y is negative. So the sign will be determined by the quadrant you land in. So D, E, F, and G, all of those points live in quadrant three. If I was to rotate it 90 degrees clockwise, this is the way of the clock, I'm going to go from quadrant three to quadrant two. And you're going to notice what would be my signs in. If I go from quadrant three to quadrant two, my x coordinate will be negative while my y coordinate is positive. So we now know that all of these x coordinates will become negative. So if I rotate 90 degrees clockwise, these will be my new points. Now that we rotated it, let's go and just plot it for fun. You don't really need to plot it. They don't really ask you to do that, but just for fun, let's plot it on our graph. So D, E, F, G prime looks like this now. And now we're going to use these points in blue, and we're going to reflect those across the x-axis. That's our second transformation. So now I'm going to take these points in blue, and I'm going to reflect them across the x-axis, and this will give us our final images, which is what we want to find. So to reflect, remember, you just kind of have to count how far away you are. So since I'm reflecting across the x-axis, that's your line that goes left and right, you just have to count how far away you are. So D prime is 1, 2, 3, 4 away from the line of reflection. So I just go 4 the other way. 1, 2, 3, 4. So D double prime will land here at -1, -4. Now for E prime, well, that's just 1 away. So I go 1 the other way. So E double prime will land at -2, -1. In fact, I don't even need to count. You're going to notice what's actually happening. When you reflect across the x-axis, the y coordinate just becomes its opposite. Instead of +4, I now have a -4. Instead of +1, I now have a -1. So F double prime is going to be really easy. The x coordinate stays the same, but the y coordinate becomes its opposite. So it's going to go from -6 to -6, but the 2 will become -2. And then for G double prime, it'll be -4, -6. So these are the coordinates for your final image. Let's just plot it for fun. If I were to reflect this across the x-axis, it would go back into quadrant 3, and it looks something like the one in red. And then we have to answer the final question. Tell whether the final images are congruent to the original figure. So remember, congruent means you have the same shape and same size. They're equal, in other words. And is the black picture equal to the red? Is it congruent to it? Yeah, it is. The final image is congruent to the original figure because rotating and reflecting a figure never changes the shape or size of a figure. You can pick up any object in your house right now, like your phone, and if you rotate it, your phone's not changing shape or size. And if you were to reflect your phone, like flip it in your hand, it's not changing shape or size. So, of course, it is going to remain congruent. So, the final image will always be congruent no matter how you rotate or how you reflect. So, this one had two different answers. The first answer is the points in red. That's our final image. And then the second part, we had to answer the question about whether it's congruent. And that's what I wrote in the bottom. I kind of wrote two sentences about it. Now let's look at number 3. I just put my quadrants to remind myself. This one wants us to translate first and then rotate 180 degrees around the origin. So once again, the first thing I'm going to do is plot my pre-image points. This is where my figure originally lies. I'm now going to do the first thing they want me to do, which is translate 2 units right and 4 units down. Well, that's really easy. You just have to count 2 to the right and 4 units down. So if I start at H, all I need to do is go 2 to the right, 1, 2, and 4 down. 1, 2, 3, 4. So H prime will land at -4, +1. I do the same thing with I. I'm going to go right 2 and down 4. And I will land here at 0, 0, 1. I can do the same thing with J. If I go right 2 and down 4, I land at 0, -2. And you're going to see what's actually happening if I just repeat that. What's actually happening is this rule. What we're doing is we're adding 2 to our x coordinate, and we're subtracting 4 from our y coordinate. So you can physically count it out like I was doing, or you can quickly use this rule and you can just add it algebraically. If this is -4y, add 2 to it, I get -2. And if this is 4, I subtract 4 from it, I get the 0. So whatever way you want to do, I actually do it algebraically because I don't really need a graph all the time. I think it's faster. But if you want to physically count it out, you can. Now that we have our points in blue, let's go and graph it. Our shape now lands here. And now we're ready to rotate 180 degrees. So rotating 180, that's the same thing as rotating 90 degrees twice. And I said in the previous example, when you rotate 90 degrees, your coordinates swap. So the first 90 degrees, xy will become yx. But when you rotate 90 degrees again, well, it just goes back to xy. So when you're rotating 180 degrees, your coordinates aren't going to swap. They're going to stay in the same position. But we're going to do the same thing. We're going to ignore the signs. So let's just take away the negatives for now. Just write them all as positive numbers. And now we're going to decide what the signs will be, once again, by talking about which quadrant they'll land in. So the sign will be determining where our signs, or the sign will be determined by where we land in our quadrants. So if we look at H, H prime is in quadrant 2. When we rotate that 180 degrees, it's going to land in quadrant 4. It's going to land in 2 quadrants away. And in quadrant 4, our signs will be positive, negative. So now it's going to be +4, -1. I prime is a weird one. I prime actually doesn't live in a quadrant. It lives on the y-axis. It lives on the positive y-axis. When you rotate it 180 degrees, it's going to look like this. 90 degrees will land here at 1, 0. But when you rotate 180, you'll land here at 0, -1. Same thing with J prime. That one lives on the negative y-axis. So when we rotate it 180, it's going to go from 0, 2 to -2, 0, and then to 2, 0, or sorry, 0, 2. So J prime will land up here. K prime lives in quadrant 3. When we rotate it 180 degrees, it's going to land in quadrant 1. And in quadrant 1, our signs are positive, positive. So we get 2, 2. And then L prime lives on the negative x-axis. So when you rotate it 180, it'll land on the positive x-axis. It'll land at 2, 0. So these points in red is my final image. This is part of our answer. Now we just have to answer the final question. Is the image congruent to the original figure? Well, yes, the black and the red image are exactly the same shape and size for the same reasoning as before. If you translate or rotate a figure, It never changes the shape or size of a figure. So it's going to always be congruent. Once again, take your phone in your hand, slide it across your desk. It's not changing size or shape. Rotate it again 180. It's not changing size or shape. Transformations keep congruency. The only transformation that changes congruency is a dilation because that actually changes the size.